So once again, I want to talk about the effect of bias in our measure of association. So again, first it's important to remember our study null hypothesis is what drives all of our studies. We have some hypothesis a priori that we state that we wish to hopefully show in our study the opposite. Okay, so for example, for conducting a cohort study, where our null hypothesis is that exposure to some risk factor X is not associated with the disease Y. And we would hope with our data to show the opposite, to show that there is an association so we can reject our null hypothesis. Our goal in all studies is to reject our null hypothesis. So we have essentially three ways of looking at this. The first is with our study, we get a value for our data suggesting there's no effect. That is that there's a null effect. And that is that the value of our parameter that we measure, be it a relative risk or an odds ratio or whatever, is pretty much close to 1 or 0, depending on if it's a relative or absolute measure, and thus there's no measure of association shown, and there's a null effect. Now, what can also happen in the presence of bias is we can have a bias toward our null hypothesis, which is we can observe an effect, some measure of association, that is weaker, smaller than the true effect. And I gave an example of this in a prior slide where I showed with the biased measurement or bias sampling that the measure of association was smaller, was closer to 1 after that bias. And so that's called bias toward the null. And then, as I also said, when your observed effect is larger or stronger than what the true effect is, then you have bias away from the null. Now, finally, you can have what's called switchover bias, which is when the observed measure of association and the true measure of association are on opposite sides of the null value from each other. So for instance, if the true value is 3 and you measure a measure of association, say a relative risk of 0.7, there you have a switchover bias occurring, which arguably is the most problematic because you can go from concluding a causal association to concluding a relationship where there's protection or some preventative association, which may be completely false and biologically implausible. So make sure you understand these different ways that bias can affect your conclusion about your measure of association as a function of your null hypothesis. So I'm going to give an example. This is a prospective cohort study to determine the association between postmenopausal estrogen use and the subsequent incidence of endometrial cancer. The group receiving estrogen is more likely to go regularly to their physicians and therefore receive more and more thorough gynecological examinations. So the question I have is, what type of bias is this, and how will it affect the relative risk? Well, first of all, it's a form of information bias because the information being collected among the individuals in the exposure arm, i.e. the group receiving estrogen, is different than the assessment for the outcome among the unexposed, so the women not receiving estrogen. So it's an information bias. How will it affect the measure of association? Well, let's think about that. If our hypothesis is that estrogen use is associated with the risk of endometrial cancer, if we're looking more closely for the outcome among the people with the exposure than we're looking for the outcome among those without the exposure, we're most likely going to get a measure of association that's larger than the true measure of association. And so that will bias us away from the null. So here's just illustrating those concepts in our 2x2 table. If we have more measurement, more frequent assessment for the outcome among our estrogen users compared to our non-estrogen users, we're going to get a measure of risk that's higher in this group than the true measure, and henceforth a larger relative risk than the true measure and a bias away from the null. Another example is a case control study of myocardial infarction in which the exposure of interest is prior intake of foods that were high in saturated fats. So among the controls in this case control study, they accurately report fat intake, but those with the outcome of myocardial infarction underreport their intake of high-fat foods because they don't want to be blamed for their heart attack. So the first question is, what type of bias is this? and the second is how will it affect our measure of association. So this is a form of an embarrassment sort of bias, and it's a form of information bias. And what it will do is bias our measure of association, in this case the odds ratio, toward the null. We will ultimately find that our measure of odds among those with the disease of myocardial infarction, or the outcome of myocardial infarction, will be lower than the true odds, and that'll lead us to an odds ratio that's closer to the null, and hence a bias toward the null. So this is just to illustrate that we're under-reporting or collecting that exposure in our case group here, henceforth the lower odds ratio. So how do we prevent bias? Well, we can do it in the design phase of our study, obviously, and that would include having a well-defined source population, including subjects who are representative of our source population. We minimize non-participation among our selected sample, and we evaluate non-participants, those people who choose to not participate, by looking at their study characteristics to make sure they don't differ from those who did participate. We also attempt to avoid self-selection and volunteer bias by randomly selecting individuals from our source population rather than letting people choose to participate. Prevention of bias in the design phase also can include a careful assessment of the controls who we want to include in our case control. We can use more than one control group in our study. That'll help to eliminate or reduce the bias. And then from a statistical perspective, it's always important to have pre-specified our power calculations so that we have an adequate sample size to actually measure what we're looking for. With respect to bias in prevention during the data collection phase, we can ensure that we select study groups prior to the knowledge of either their exposure or their outcome. We will use or develop and use standardized tools to collect either the outcome or the exposure, depending on the study design. Importantly, that those measurement techniques are applied equally and uniformly to all of our groups in our study. It's important to train staff involved in our study collection and to test them and retest them, as well as to train and retrain. And also during the conduct of a study, particularly a cohort study that has a long period of time associated with it, it's important to look at measurement drift to assess for validity and repeatability of our collection, as well as to assess what's called inter-rater reliability, looking at the relationship and outcome measurements between individuals who are collecting data, as well as within the same individual. And this can be performed during the conduct of the cohort study to assess for any differences as a function of time, change in staff, change in population that can affect our measurement. Also, we can measure the disease, this is very important, without knowledge of exposure, and measure exposure without the knowledge of the disease. This is important in all of these studies I've talked about. If it's a cohort study, we need not know that exposure status when we're looking for disease, and vice versa for a case control. It's important to use valid and reliable measures for disease and exposure when they exist, and if they don't exist, we tend to use multiple measures so that we get some sort of consistency across those measures. We assess bias between those who we attempted to recruit for our study and those who were enrolled, as well as assess bias between those who remain in the study and those who drop out. So looking at characteristics among those different groups will help us to determine if we have bias in our study sample or in our information.